Hello everyone, welcome to our first video for week 7. In this week we're going to be taking a look at interfaces, and then we're going to be taking a look at how to implement these interfaces in the scenario of the comparable interface. So very briefly, an interface is going to define a protocol of behavior, and essentially if a class is going to implement an interface, it must adhere to that protocol that is going to be defined by the interface. So essentially, for an example here, let's just take that we have a drivable interface. This public interface drivable is going to have a few methods a part of it: public void start, public void stop, public void accelerate, decelerate, and then turn. And essentially what will happen here is that we can implement a bunch of different cars, maybe like a Toyota or a Ford, and these cars can implement this interface, and they will all share these items here. So again, we are not doing inheritance here when we're implementing interfaces. We are relying on an interface to define a custom set of a protocol of behavior that is going to be shared throughout a bunch of different vehicles. So essentially in here, we might have a car, truck, van, and a snowplow, and each of these methods might be a bit varied in how they are implemented. For instance, maybe they can accelerate a bit more in a car than a snowplow. But again, the general idea is that all of them will be sharing these types of methods. So all of them need to speed up and slow down and so forth. Excellent. So after we go ahead and take a look at the concepts of an interface, the one that we see most prevalently used is this comparable interface. So a comparable interface is something that allows our interface objects to be ordered, or whatever is implementing that object to be ordered. And then, for instance, the integer, double, and string, and Boolean as well, all implement this comparable interface. The way that we use this comparable interface is after we go ahead and we implement it in our code, we are forced to use this compareTo method. And what this method does is it returns a negative integer if the calling object, or essentially whatever object is on the left side of compareTo, is less than the argument provided, 0 if the argument on the left is equal to the one on the right, and then if the one on the left is more greater than the one on the right, it will return a positive number, or a 1. So -1 means it's less than, 0 is equal, 1 is greater than. Now note that string, double, and integer are all classes that automatically implement this, and they are considered to implement this comparable interface. Now you'll notice here that the header of our public interface for comparable is this has this little interesting thing called T, which is again just this type. So you'll see here, when we want to alter our method to use the comparable interface, we must include the type T in our header. This is shown below in this example, but essentially what happens here is that when the type T is what we refer to inside our methods when we want to discuss the type of our objects. So T can be considered this kind of generic placeholder. Let's just say that you have a dog class, or a person class, or a shape class. You can implement the T there to be the type for being a catch-all. Great. So after we go ahead and implement this, we're going to kind of look at how this actually works out in this file called search.java, which is inside of your Java files provided. So again, when we do this searching algorithm that we saw earlier, we took a look at finding the smallest element in an array. The general steps, again, we're declaring an integer variable mid position, setting that to be equal to the first index, looping through our array, and then asking this question here: if the element at the current index is less than the item at min position so far, then set min position to the current index. After the loop is done, we return the item at min position. So we'll see here that this is working out pretty well for integers, but what happens if we want to do it for strings? So we'll see here that primitive comparisons, such as like the ones that are built in, are not going to be applicable to objects like strings. So we're going to have to rewrite the method to use the compareTo method. And there's actually code inside the search.java file that does it for us. And let's take a look at the search.java file. And as a regular reminder, the files from this week are going to be shapes and week 7. They're in different files here, but you could go ahead and combine them if you'd like. We keep them separate just for the concept of protected items. Let's take a look at our search file, and I kind of deleted a few things here to go ahead and showcase what's going on in this file, but we can kind of read through it together. If I run this here, it says I have an X, okay? So it's running okay. And we'll see here that we create a number array of integers, and then we use this find max int of this numbered array. So if we go down to find max int, what this does is it takes in an array of integers, and then it simply says, okay, what's the largest item seen so far? and it's 2. And then we loop through every item in the array. If we find an item that's larger than the current one we're on, we set the max to be that item. And then we print out at the very end, largest array element is number 6. And then we return that position. So this is a very straightforward way of approaching integers. Let's go ahead and make a string array here. And in this string array, we'll see that the index is at the find max string of strings. So if we go ahead and look at find max string, we'll see here I get a string array of values. I set my min position to 0. And then I say for int of index 1, index is less than values dot string index plus plus. If you'll notice here, I get this value that I need to use. So right now, if I just say values of index, and instead of using this compare to, I do less than values of max position, you'll notice I get this error right here. The operator less than is undefined for argument types java.lang.string, java.lang.string. So what that is saying to us is that you cannot use a less than symbol to compare John to another string like Duchess and so forth. So that is not going to work in Java. So how do we fix this Java error? Well, we can use the dot compare to, and we'll notice here that compare to is going to return those items that we saw. So we'll see here that I cannot convert from int to Boolean. So again, what does compare to return for us? Compare to returns a negative value if the object is less than the argument, 0 if they're equal, and then 1 if they're, a positive number if they're greater than. So what I could say here now is that if the current item is greater than our 0th, or is greater than 0, if the return result of this function is greater than 0, then I'm going to go ahead and update that position. So what should happen here is I should get testing right away. And let me go ahead and add in one more item here that's going to be the longest one. Maybe Mississippi. It's a longer one. I think I spelled that right. And we'll see here. Oops. Yeah, the 3 of them here. We'll see now that my testing at multiple times, when I have a larger string of testing, I get it repeated a bunch of times. So that is going to tell us what the largest item in the array is. And we'll see here, what if I want to find the smallest one? Well, what I can edit in my find max string function is what if I make this less than 0? Let me try to run this now. We'll see here that I get, it's saying the largest element, but let's just say that this is trying to find the smallest one. What I'm getting now is that I will get the Chad back because that's the 4-letter one. And if I go ahead and I just put it in A here, see here, we'll see the code is a little wonky because it's testing for max, so the message is going to be a little weird, but we see that I get the A now as well. And the only reason this is happening right now is because I'm changing this item down here, which returns a 0 if it's equal to, less than 0 if it's less than, and then greater than 0 if it's greater than. So again, this will find us the largest value in the array. Go ahead and update this a little bit here. Cool. And it'll be working okay. So again, this is kind of how that compare to method works. And we'll see that it's a bit different from what we've seen. But again, if you actually go ahead and simply in your main method, try to experiment a bit with compare to. Let me just do this really quick for us. Compare to will always return numbers for us to work with. So if I do ahead and I print out a line of, let's say, John.compare to, and I'm going to compare it to Duchess here, and I run this guy, we'll see that I get a number of 6, and this number changes all the time. Let's see if I say testing and testing now, and if I print this one out, we'll see that I'm getting a more positive number as well. And in general, what this does is it takes in these two objects and it will return a range of values, either in the negative or positive, based on what the outcome should be. So again, negative if the object is less than the argument, 0 if the two objects have equal values, and in a higher number than that one. So let's go ahead and try to do a test. And we'll see here that I now get 0 because these two ones are the same. You're seeing here I get this 6. Strings can sometimes be a little bit odd. Let me go ahead and try to make this an A here. And we'll see, what if I swap around A with Duchess here, we'll see now that I'm getting a negative 29. So because this A is being compared to this Duchess here, I get a negative value, and essentially you can work that into your code there. So again, when you're using compareTo with strings, you don't need to worry about the exact value. You just need to check if it's at 0, below 0, or greater than 0. Awesome. So that's a bit about our compareTo and how these interfaces work. And what we can do here is let's take a look at the search.java file one more time, and I'll uncomment the items here. I'll actually leave them. I'll leave them commented for us to work with, and we could just go ahead and kind of uncomment this find max string. But again, this find max string is checking for the 0 if it's greater than 0, because again, what happens if this one is less than this one? We're going to get a negative or a positive number, and then that will tell us what the max position is there. So that is essentially what the compareTo does. In the next one, we're going to take a look at creating a new class that implements comparable. So we're going to make a custom class called person, and we're going to try to compare people using that class.